लाइव हो गया क्या? Very good evening, guys. Good evening to all of you. I hope you people are fine and your preparations are going excellent. Let's start today's lecture. Let's not waste any more time. Starts today's lecture. So, guys, for those who don't know me, my name is Manish Mishra. I secured an All India rank of 568 in GATE 2015, and since then I have been teaching for GATE and ESE. I have a cumulative experience of 5 years now in teaching. Good evening, Amol. I am fine, my friend. Good evening, Manikandan. This is the first time I am seeing you guys live. Good evening, Abhishek. So, guys, the subjects that I primarily take are manufacturing, industrial operations, research, and material science. If you will just take a look at the subjects that I take, you will understand that this is basically the entire section 4 of the syllabus of GATE. And remember, guys, section 4 itself has a weightage of 25 marks. The most easiest of the lot of the entire syllabus of GATE Mechanical, section 4 is the easiest and is the highest scoring section. Okay, so duality theorem किस लेक्चर में है? Abhishek, I think it is in the last lecture of LPP. Duality theorem is in the last lecture of LPP, right? Last lecture of LPP में है duality theorem. So for those who do not know about this, I started a series on the Unacademy special classes by the name of Manufacturing 2020. In this series, in just 20 days time, I targeted the entire subject of manufacturing, including material science and metrology. Okay, Abhishek, don't worry. I will coordinate with the Unacademy team and find out why the lecture is not there. Meanwhile, you can do one thing. I have made a series of linear programming problem on the special classes. You can check out that. If it is not on YouTube, go check out that. Okay? So in this series, my friend, in just 20 days time, I targeted the entire manufacturing, including metrology and material science, and through which you can fetch 20 marks in the GATE examination, as I mentioned. That section 4 has a weightage of 25 marks, out of which 20 marks come from manufacturing, metrology, and material science, and 5 marks belongs to industrial engineering and operations research, right? This series is absolutely free, but if you want to watch these free classes, do remember to use the referral code MMM10 to unlock your free plan on the Unacademy app. Guys, this is my profile on the Unacademy page. If you want to access my profile, you can straight away scan this QR code using your mobile phone camera and you will be directed towards my profile page. Just simply follow me there and you will be able to receive all the notifications of all my lectures which are going to be upcoming, right? लास्ट लेक्चर में यूनिट वर्क पढ़ाया था एलपीपी के लास्ट लेक्चर में एंड उसके बाद वर्क स्टडी स्टार्ट कर दिया था आपने. अच्छा अभिषेक, हो सकता है, पॉसिबिलिटी है कि मैं शायद उस छोटे से चीज को कराना भूल गया हूँगा, बट स्पेशल क्लास में मैंने कवर किया है. दैट आई रिमेम्बर वेरी वेरी स्पेसिफिकली. सो यू कैन चेक आउट द स्पेशल क्लास, वहां पे आपको वो कवर हो जाएगा. और मैं एक छोटा सा सेशन ले लूंगा जहां पर मैं थ्योरम ऑफ डुअलिटी को एक्सप्लेन कर दूंगा. ठीक है? सो गाइस, this is my Telegram group chat QR code where I provide my notes, practice booklets, notifications of my classes, guidance, and many more things. So if you want to be a part of this Telegram group chat, simply scan this QR code and everything will be unlocked for you. सर पीआई के इंडस्ट्रियल का कुछ इंपॉर्टेंट टॉपिक्स प्लीज बोलिए. अर्का चटराज. Okay, the thing is, Arka, that if you go and check out the GATE question paper of PI, the topics that I am basically taking right now, or the topics that I have taken in these 44 lectures, these are the most important areas from where questions come in the PI paper also. Yes, there are definitely some other topics also in the PI paper, but please remember those topics are not that relevant. The topics which are relevant corresponding to the mechanical as well as the PI paper, I have covered those topics in these 44 lectures. Definitely the PI syllabus is a bit vast corresponding to the industrial and operations research, but you can prepare these topics from these 45 lectures and you will be benefited, right? Don't worry about this, okay? But if you want me to take some specific topics, do WhatsApp me or give me a text message, or you can give me a call also, and I will arrange those topics on the special classes. But sorry, my friend, I cannot conduct any more classes on YouTube because the time that I was allotted, it was up to the 31st of December. These last lectures that I am taking, I am basically pushing the team so that they can allot me some more time, because they have created a new schedule for me in which I have to take the revision classes in the month of January. So sorry guys, I cannot continue the YouTube session of this particular module, the crash course of industrial and OR. Okay, now चलो रे भाई, चलो स्टार्ट करते हैं. Let us start the topic of industrial engineering and operations research. And in this module, my friends, yesterday we were discussing quality control. So in quality control, I have already discussed the basic concept. I have discussed what is Six Sigma process. I have discussed the 3 Sigma, 6 Sigma, 12 Sigma, all kinds of process. I have discussed what is a control chart. I have also discussed when to use a control chart, and I have explained you the standard normal distribution and the use of control chart via finding the control limits and the specification limits, right? How much portion has been left after this lecture? This is the last lecture, my friend. Abhishek, this is the last lecture, right? I mean, end. Nothing is left. Okay. So yesterday I told you guys that control charts are of two types. One is the variable control chart, where the quantities that we are looking forward to control can be measured, like they are variables like time, weight, distance, temperature, they can be measured. So continuous distribution function is used, and the normal distribution function is a continuous distribution function. So variable charts are X bar R chart. They are both depending upon the concept of normal distribution. ठीक है ना? I have also told you that X bar chart is important with respect to the gate examination, but R bar chart is not that relevant because they will have to provide you with a table in order to solve the questions of R bar chart, right? Now another type of control chart was attribute chart. So guys, in yesterday's class I discussed the questions. Hi Gino. In yesterday's class, I discussed the questions of what, X bar and R chart, and variable chart was over in yesterday's class. Today I was about to start the attribute charts. Okay, so there are four type of attributes chart: P chart, NPC, and U chart. And remember, attribute means yes or no, presence or absence, right? I have gave you an example also of go and no go gauge, right? So if I keep on measuring the diameter, then it is basically a variable chart. But if I just look for the go and no go gauge, then my friend, it is an attribute chart. With the help of go and no go gauge, I basically define the success or the failure, the accept or the rejection of a particular shaft, right? So today we will discuss the attribute charts. And remember my friends, because attribute charts talk about the attributes, like if they basically give me a shaft, they are asking me whether it is to be accepted or to be rejected. ठीक है ना? So there is one more thing with the help of attribute charts which we can find, and that is the number of defects. Remember, I am not talking about number of defectives, I am talking about the number of defects, my friends, right? सर ये गेट सिलेबस में है? अरे हाँ भाई आशीष, ये गेट सिलेबस में है. I discussed this yesterday also, that this is very relevant with respect to the gate examination. In 2019 paper, one question also came from this topic. So it is relevant with respect to the GATE examination, right? So guys, please remember that graduate aptitude test in engineering, I mean, for the past couple of years, they have been experimenting a lot. I mean, in from many of the subjects, questions are coming from those areas which were not explored earlier. So there was a time in 2012 and 13 when students just used to take the GATE previous year questions and they prepare everything using the PYQs and just straight away go to the examination hall by mugging up the formulas, and they used to score 55, 56 marks and used to get all India rank 200. But now that is not the case. The syllabus has expanded. The expanded in terms like because GATE is conducting the examination in such a way that they are exploring new avenues to put up questions in the paper. So guys, as an educator, I it is my responsibility to teach those stuffs to you guys so that you guys can be prepared. Now it is entirely depends on you, that I have made 45 or 44 lectures, but it depends on you whether you want to watch all the lectures or not. If you feel like 4 or 5 topics are enough for you in order to write the GATE examination, you do that, you prepare 4 or 5 topics, but it is not advisable from my point, it is not advisable from my side. Okay, so yes, Ashish, it is there in the GATE syllabus. Good evening, Sonu. So guys, let us start. Okay, let us start the attribute charts today. Before attribute charts, before I start attribute charts, there was a very small topic from which a question came in the GATE examination, and that topic, my friend, was process capability index. Now, what is process capability index? Process capability index is represented by CP and is given by the relation USL minus LSL upon 6 sigma, right? So guys, what is the meaning of this? I mean, yesterday I explained this to you. Yesterday I explained this to you that the mean is basically distributed as per the normal distribution. The mean is basically distributed as per the normal distribution. Hello Anshul. Today my friend Ashwin is not there. Today my dear friend Ashwin is not there. And a couple of more of my regular students are absent today. I don't know why. Maybe they are present, just not commenting today. Okay. So I was explaining that there was a upper specification limit in the design zone. And I always make this mistake. There was a upper specification limit and a lower specification limit. Oh, Ashwin is there. Ashwin is there. There is always a upper specification limit and a lower specification limit, and then there is the mean value, that is the X bar, right? But guys, I told you specifically yesterday that when we design, we select when we are talking about the designing, ठीक है ना? So designing, we consider the lower specification limit and the upper specification limit, but when we start manufacturing, we talk about the upper control limit and the lower control limit. Upper control limit and the lower control limit. So suppose the design curve is like this. Suppose the design curve is like this, with this value as the lower control limit, this as the upper control limit. This is the lower control limit, this is the upper control limit, and this range, my friend, let's say is 6 sigma. This range is 6 sigma, okay na? So if USL minus LSL, that is this range, is large, is greater than this range, that is 6 sigma, if USL minus LSL is larger than 6 sigma, then that means that whatever we are manufacturing is well under the specification limits of the design, and all the shafts that will be produced via this method or this process will be acceptable. So that means, my friend, that if I write USL minus LSL upon 6 sigma and CP is greater than 1, then I say that the process is very much capable. Everything is well under control, and the control charts are basically giving the values under the lower control limit as well as the upper control limit, which are well under the lower specification limit and the upper specification limit. I hope you are getting my point, right? So if the value of CP, my friend, if the value of CP is greater than 1, then everything is well under control and we call the process capable process. But if the value of CP is equal to 1, that means the lower control limit is coinciding with the lower specification limit and the upper specification limit is coinciding with the upper control limit. So although whatever we are producing is under the design limits, but it is on the verge of shifting, it is on the verge of a very critical moment that any variation, any change will lead us to outside these boundaries and shafts will get rejected. So I will say if CP is equal to 1, it is just capable. But if CP is less than 1, if CP is less than 1, then definitely this range is smaller than this range and the shafts are producing are out of the range. They are a rejected shaft and we say that the process is not capable. So based on the process capability index also, we can define that whether the process is well under its limits or not, or whether the process is under control or not. I hope you got my point, right? So using this also, we can calculate this, and questions have came in the gate examination on this particular topic. So if you will find some question now, just simply straight away solve them. Okay? It is very easy. Now my friends, this is one question. This is one question, and in this question, it is said that 4 batches of products are inspected at 90 minutes interval and their percentage difference in way from the nominal are given below. Okay, assume the normal process average variation. Normal process average variation is 9%. Normal process average variation. So we have given the average value as 9%. Average value is being given to us as 9%, and the process standard deviation is 0.5%. So sigma have been given to us as 0.5%. Now it says use X chart and determine the lower and the upper control limit on the X chart. Let me take on my calculator. So 4 batches are talking, we are talking about 4 batches of products are inspected. Okay, na? Now these 4 batches have been given to us: batch 1, batch 2, batch 3, batch 4. In these 4 batches, you can see we have taken 5 samples. We have taken 5 samples, 1, 2, 3, 4 and 5. So n will be equal to 5. The sample size will be equal to 5. And remember my friends, on the X bar chart, let me just show this to you so that you guys can remember. Let me just show this to you so that you guys can remember. On the X bar chart, the upper control limit and the lower control limit are given by this relation. And let me move back. Okay, so here I was. So the upper control limit is equal to X bar plus 3 times of sigma X, and the lower control limit is X bar minus 3 times of sigma X. If they do not talk about the value of Z, always consider it to be 3. If they do not talk about the value of Z, always consider it to be 3, right? So upper control limit, lower control limit is this. So I can find now, I have the value of X bar, which is 9%. So 9%, my friend, is 9%, my friend, is, it is 9%, right? X bar is 9%. Okay. Assume that normal process variation is, average variation is 9%. Okay. Sorry guys, I have made one mistake. This is not mean, right? We will have to find the mean. That way, that means we will have to find the averages of these. Like if this is x1, x2, x3 and x4, so we will have to calculate these. So we will have to average these values first, average these values first. So it will be coming as 1.2 plus 1.8 plus 1.5 plus 0.9 plus 0.3. So this is coming out to be as 5.7 divided by 5, that is 1.14. 1.14. Now let us consider this one. So this is 0.6 plus 0.3 plus 0.3 plus 0.3 divided by 5. So this is coming as 0.3. Now let us talk about x3. So this will be 0.6 plus 1.5 plus 1 plus 1.9. 0.6 plus 1.5 plus 1 plus 1.9 divided by 5. So this is coming as 1. This is x3 is coming as 1 and x4, my friend, is coming as 1.74. So I have simply taken the averages of these values. Right? Now what I can do, if I want to find the value of x bar, I can use x1 plus x2 plus x3 plus x4 divided by 4. So this will be coming out to be as 1.14 plus 0.3 plus 1 plus 1.74 divided by 4, my friends, is coming out as 1.045. So x bar is equal to 1.045, right? Sigma has been given to us as 0.5%. Sigma has been given to us, the standard deviation is given to us as 0.5%. So I can straight away take it as 0.5. I can straight away, because all these values are in percentage. Right? I hope you people are getting my point. So now I will write upper control limit is equal to x bar, that is 1.045 plus 3. Instead of sigma x, what we can put, sigma dash by root over n. So this will be sigma dash, that is 0.5 by root over n, the sample size, which is 5. So this is 5 here. So this is coming out to be as 1.045 plus 3 times of 0.5 by root over 5. So this is coming as 1.715. 1.715 is the upper limit, and the lower control limit will be good evening Shreya. Lower control limit will be 0.374. I hope you got the solution. I hope you guys got the solution. Nothing more than this. This is the only relation that is there on the x bar chart. Remember, in place of sigma x, we can put sigma dash upon root over n. Okay. I hope this is perfectly clear to you. I have also solved one question in the previous class. And I have shown you guys that how to solve this question. I have discussed all the relations and formulas, and I hope this is kind of a revision for you. Now guys, let us move on to the next topic, that is the P chart. Now guys, the number one thing that you should understand before we move on to P chart, that is, here we are talking about proportions of defects. Up until now guys, we were discussing variable charts. And remember, in variable charts, the quantities can be measured. Whatever the things that we were discussing using the X bar or the R chart, they were variables. They can be measured. So if I can measure time, I can measure weight, I can measure the dimensions, then they are basically continuous function. Like when I talk about measurement, then I can say that there is a measurement like 24.5 centimeter also. There is a measurement like 24.5 centimeter also. But my friends, now we are starting attribute charts, right? In attribute charts, we talk about defects. Now we cannot say that there are like 4.5 defects in a shaft, right? If I have created certain criteria that in a shaft there can be cracks, there can be deformation, there can be indentation. Like I have created a category where there are 10 types of defects. So out of those 10 defects, there can be 3 defects, 4 defects, 5 defects, which can be integer. but it cannot be a decimal or a rational value. I hope you are getting my point, right? Like we are talking about attributes, so attributes are to be in integers only, they cannot be decimal or fraction. So guys, number one thing that you should understand, that while we talk about the attribute chart, the function that we are to be considered is a discrete function. It is not a continuous function, it should be a discrete function. And the discrete function should be such that it can decide the quality factors or it can control the quality parameters, right? So we have already discussed that normal distribution is what the probability density function which covers the entire domain of quality control, whether from 3 sigma, 4 sigma, 5 sigma, 6 sigma or whatever it is. Okay, na? So from normal distribution we obtain the binomial function or the binomial distribution, which is basically a discrete function, but the entire distribution chart, the entire distribution curve is exactly like the normal distribution. So normal, we can say that binomial is the child of normal. And one more thing, through binomial we have obtained Poisson distribution. Through binomial we have obtained Poisson distribution. Remember in PERT CPM I have told you guys that the PERT graph is like normal distribution curve, but basically the project duration in PERT follows the Poisson distribution function, right? Poisson distribution function. Why? Because when I talk about the completion time of a project, I am basically talking about an integer value. I hope you are getting my point, right? So Poisson distribution function was there, which is nothing but the, let's say, the brother of binomial distribution. So binomial is the child of normal distribution and binomial and Poisson are, let's say, brothers. Okay? So basically these functions are more or less same. These functions are more or less same. The only difference is that binomial function and the Poisson function, binomial function and the Poisson function, my friend, are discrete. They are not continuous. Okay? So when I talk about discrete, that is basically suited to the attributes, because attributes are to be in integer, they cannot be rational. I hope people got my point. Now guys, number one chart that we have to discuss here is the P chart, right? So before we discuss any of the charts, let us first understand binomial distribution a bit. Okay, na? So let us first understand binomial distribution. So I think you guys can recall these relations as we have already studied them in 12th standard. So probability of binomial distribution is given by the relation PR is equal to NCR PR 1 minus P N minus R, where P equal average fraction defective, N equal number of samples, and R equal number of defectives, right? So let us understand this, and before I proceed, let me tell you one thing which will help you to choose that in which question or in which zone, in which area you should be using the P chart, where you should be using the NP chart, and where you should be using the C chart, right? So whenever they talk about the proportion of defect, proportion of defect means like if there are 100 defects and I am saying that 70 out of 100 are there in a particular system, then I can say that 70% or 0.7 or 7 by 10 or 70 by 100 portion of the defects are there. I hope you are getting my point. So whenever we are talking about the number of defects in a lot, the proportion of defect, how many of the defects are in proportions, right? Like for 100 it is 70, then for 200 it is 140, then for 300 it is 210. I hope you are getting my point, right? So if I am talking about the proportion of defect, then my friends, I will be using the P chart, right? But if I will be talking about the number of defectives, if I'll talk about the number of defectives, then I will use the NP chart. What is the meaning of this? When I say that 70 out of 100 are defectives, like the proportion that I have given, the proportion that I have given, if it says that out of 100, 70 are defective, then if somebody asks me what are going to be the number of defects in 500 shaft, what is going to be the number of defectives in 500? So I will write 500 into 0.7, that is 350. I can calculate the number of defects, right? So how I have done this? How I have done this? Whatever may be the sample, I will write this as N, and whatever be the proportion, probability, I will write that as P. So N into P will give me the NP chart, and in NP chart, my friends, I will calculate the number of defectives. 350 is what matters to me, but in case of P chart, the proportion matters to me. 7 by 10 or 70% or 0.7 is what matters to me. I hope people got my point, right? So a probability of a binomial distribution is given by the relation PR, right, where N is the number of sample what I have tested, R, my friend, is the number of defective, P, remember in class 11th and 12th, P is the possibility of an event, and 1 minus P, the event not happening. I hope you got my point. The formula was NCR, PR, Q, N minus R. So instead of Q, I have written 1 minus P, because if the total probability is 1, then if P is the number of events that are happening, then 1 minus P is basically Q. That means the number of events that are not going to happen. So if I am talking about P is the average fraction defective, then 1 minus P is that part, that value which is not defective. I hope you are getting my point, right? Now, 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 the average defect is given by the relation NPQ. I hope you can remember this, where Q is nothing but 1 minus P. Q is nothing but 1 minus P, right? So guys, if I talk about in an NP chart the number of defectives, right? So in an NP chart, my friend, in an NP chart, I will write, in an NP chart, I will write it like this. Let me just rub this. In an NP chart, I will write like this. Number of defectives NP chart is equal to NP plus root over three times of root over NP 1 minus P. Okay. Now, let me just correct this. Average defects is given by the relation NP, and error is given by the relation NPQ. Okay? Keep in mind these two values, average defect and error. Now guys, if we talk about the upper control limit and the lower control limit. So remember, upper control limit is x bar plus 3 sigma, whereas lower control limit is x bar minus 3 sigma. So this x bar is basically the mean value or the average value, and what is this, my friend? This is basically the error, I can say. This is basically the error. This 3 sigma is the error. Otherwise, every value we want to be on the 25. I hope you are getting my point. If Tata Motors has given me a range of 24 to 26, so that is because there is going to be errors, na? Otherwise, they would have asked me for a shaft of 25 centimeter. The mean value is 25. How much we are deviating from 25 is basically the error, right? So in case of NP chart, if I write the upper control limit, then in case of X bar, what I can write? In case of X bar, what I can write? The average defects, that is NP. And in case of error, what I can write? Plus 3. So standard deviation sigma or error is given by NPQ. Standard deviation is NPQ, right? So remember, that is the variance. So variance is square of standard deviation. Variance is square of standard deviation. Let me just write the formula in that way, otherwise you people will get confused. Let us remove error from here and write variance. This is the formula of mean, this is the formula of variance in probability of binomial distribution. I hope you can remember this, right? I hope you can remember this. So NP plus 3 times of root over NP 1 minus P. So this is the upper control limit, and what is the lower control limit? NP minus 3 times of NP 1 minus P. Now guys, this I have written for the NP chart, and I have already told you that if I have the P value as 0.7, okay na? And this 0.7 basically shows that 7 out of 10 are defective. The proportions 0.7, 70% is defective. Then basically multiplying this P by N, NP, so whatever may be the sample size, whether it is 1000, 50,000 or 1 lakh, if I simply multiply it by that, I will get the number of defectives. I have already explained you this, that through the P chart, multiplying with the number of samples, I can calculate the number of defectives. So here I have calculated the number of defectives. This is the last lecture, Anand. This is the last lecture. Here, my friends, I have calculated the number of defectives. So if I want to write this for the P chart, then the upper control limit for the P chart, I will divide this by N. I will divide the NP by N, and N will get cancelled. I will get the P chart. I hope you get my point. So dividing this entire zone by P, I will get P plus 3 root over NP by N. Sorry, this is NP by N. So P 1 minus P upon N. Okay, na? So this is the relation for P chart for the upper control limit, and for the lower control limit there will be minus sign here and nothing else. I hope you got this. These are nothing but the conversion of these formulas which we have obtained in general. These were the general relations using the normal distribution, but by converting them into the binomial distribution and using the values of mean and variance of binomial function, I have just calculated the value for the NP chart as well as for the P chart, right? So these are the various formulas for them. I have also discussed the C chart, and what is basically a C chart. Again, the thing is going to be very similar. If I have to find the control limit, then the control limit is basically given by the relation C plus 3 root C, where C, my friend, is the number of defects, right? So when they talk about the number of defects, not the number of defectives, when they talk about the number of defects, like here they have talked about the proportion of defects, right? Proportion of defects. So proportion of defects means that out of 170 are defective, right? Proportion. When I talk about the number of defectives, how many shafts are defectives? Thank you, Anand. Very nice of you to say this in the comments. Otherwise, students don't comment at all. So in C charts, my friend, we are looking for the number of defects, not the defectives, right? A shaft is defective, that is a different thing. But if I'm talking about the number of defects in the shaft, whether it has 2 defects, 3 defects, whether it has a crack defect, a line defect, a dislocation, a indentation, anything else. If I'm talking about the number of defects, right? So the difference is that through P chart you calculate the percentage or percentage of defectives. Through the NP chart you calculate the number of defectives. So whenever they will ask you about the number of defectives, or in the question they have given the number of defectives, always use the NP chart. Whenever they are talking about the proportion or the percentage of defect, use the P chart. But when they ask you about the number of defects, 2 defects, 3 defects, 4 defects, use the C chart, right? And what is the C chart, my friends? In the C chart, the control limit is C plus minus 3 root over C, where C is summation of C by N. And what is summation of C by N? Don't worry, I will deal one question, and through that I will explain each and everything to you. Now guys, check this out. Check this out. Here is a table that I have made for P, NP, C, and also for the U chart. Now this is not that much relevant because this is for the variable part. सर कोई ESE GS फ्री कोर्स अवेलेबल है क्या? Sorry Maninder, I don't know, but please go check on the Unacademy app. Definitely there will be special classes where somebody from the ESE field must have taken the GS section. ठीक है ना? On this YouTube channel, no, it is not available. On this YouTube channel, it is not available because you must have seen the name is Unacademy GATE MEPIXE, right? So ESE, the paper 1 is not covered here. So definitely you will have to check the Unacademy app in the special classes category. Someone might have done that, or you can check out that channel, GATE and ESE channel, right? Now, let us take on this question. So in this question, as you can see, percentage defective is what we have talked about. So whenever we talk about the percentage defective, I have already told you that for percentage or proportion, we will use the P chart, right? So guys, a person operates a machine and makes capacitors. He has been advised to keep track of the percentage defective at his work center. He knows that this type of process, they expect about 4% defectives plus or minus some chance variation. He wishes to construct a control chart for defective. He has prepared 10 daily samples of 100 capacitors each. I hope you can understand this. 10 groups of 100 each, right? So there are 10 samples, but each sample has a size of 100. So for us, the value of n is 100. I hope you are getting my point, right? I hope you are getting my point. So they have given us the data that in sample 1, 4% are defective, in sample 2, 3% are defective, and so on. The data has been given to us. And they have asked us to find the UCL and the LCL, that is the upper control limit and the lower control limit. Now remember, at upper control limit in the P chart, upper control limit in the P chart is given by this relation, So let me just write this for you. P plus 3 root over P into 1 minus P into 1 minus P whole divided by N. Okay. So they have given that the expected or the mean is 4%. The expected or the mean is 4%. So let us take instead of P, because they are expecting this much defects and P is the probability of defect. They are expecting this much defect and P is the probability of defect. So I will write 0.043 root over 0.041 minus 0.04 divided by 100. So let me just solve this. Let me just solve this. Remember, this is not cube root, it is 3 times root, right? 0.04, 1 minus 0.04, 0.04, 1 minus 0.04 by n, that is 100. So this is coming out to be as 0.098, but 0.098, remember, it is 9.8%. 0.098 is 9.8%, right? And the lower control limit is instead of this plus, I will use the minus sign. Instead of the plus, I will use the minus sign. सर टेलीग्राम चैनल पर आपने जो क्वेश्चन दिए थे वो नहीं मिल रहे। अनंत अभी थोड़ी देर में मैसेज करना, क्लास के बाद जो चाहिए होगा मैं फिर सेंड कर दूंगा। ओके, सो लोअर कंट्रोल लिमिट इज व्हाट? Lower control limit is what? 0.04 minus 3 times of root over 0.04, 1 minus 0.04 by 100, right? So this is coming out to be as minus 1.87. So just consider this as 0. The lower control limit cannot be negative. Why it cannot be negative? Because we are talking about the percentage defective, right? And percentage we know is from 1 to 100. Percentage is know we from 1 to 100. So the upper limit is 9.8 and the lower limit will be 0 because it is coming out to be as negative. Okay? So now guys, is the process under control? Yes, Ashwin, it is coming out as negative. So just consider it as 0. Okay? So now is the process under control? So the mean that we have talked about is 4%. The mean that we have talked about is 4%. The upper control limit x bar is 4%. The upper control limit I have calculated as 9.8%, and the lower control limit, my friend, is 0%, right? So now you can see 4, 3. So if I keep on drawing, so this is 4, like this is the first point, then there is a 3, then again there is a 3, then there is a 6, then there is a 1, then there is a 9, then there is a 5, then there is a 12, right? Then again 4, then 3. So this is basically coming out to be as something like this. Something like this. And as you can see, one of the value is outside the upper control limit. So no, the process is not under control. Okay, na? The process is not under control because one of the values, like this zone, this sample, the defectives are 12%, which has surpassed the upper control limit. So guys, definitely this operation is not going proper, and we need to make certain changes to the operation so that it can shift towards the mean value of 4%. I hope you got this, right? I hope you people understood this. Do you want me to repeat or anything like that? Do you want me to repeat or anything like that? These are very easy questions, my friend. Very easy questions. Now guys, check out this another question. In this question, they are talking about the number of defects. So remember, I have written this here very specifically. Proportion of defect P, number of defectives NP, but number of defects when they talk about it will be C. So here they are talking about number of defects. So remember, we will be using the C bar chart. We will be using the C bar chart. Okay, na? So how to use the C bar chart? How to use the C bar chart? So they have given us that in a sample of 20 casting, shown below, the number of defects are that in sample 1 it is 76, 68, 76, 89, 47, 69, 83, 93, 70 and 79. These are the defects. Now these values are basically the values of C. these values my friend are basically the values of C, ठीक है ना. So how to calculate? Remember that the control limit is given by the relation C plus minus C bar plus minus 3 root over C bar, right? So this is the relation. This is the relation that we are talking about. So guys, in order to calculate C bar, what we need to do is, in order to calculate C bar, what we can do is, we can add up all these values. So 76 plus 68 plus 76 up to like 79 and divide this by 10, just average it. So this will come out to be as 76 plus 68 plus 76 plus 89 plus 47, 69, 83, 93, 70, 79 divided by 10. So C is coming out to be as 75. Now the control limit I can write 75 plus minus 3 root over 75. So this will be coming out to be as plus 3 root over 75. So that is 100.98. 100.98, that is the upper control limit, and the lower control limit will be with a minus sign. 75 minus 3 root over 75. So this is 49.01. 49.01. So if I draw the chart, so the mean is 75, the upper limit is 100.98, and the lower limit, my friend, is 49.01. If you will plot these values, you can see that no value is above 100. But check this out, one value 47 is below 49.01. So this process is not under control, right? This process is not under control. It has been asked in the question, is the process under control? So no, the process is not under control, because in one of the samples the number of defects have surpassed the lower control limit, and if we have surpassed the lower control limit, that means our quality is not up to the mark. Okay? So I hope this is clear to all of you. I hope this is clear to all of you. And guys, now let us start MRP. Okay? If I am going fast, then please intimate me. If I am going fast, then please write, sir, you are going fast. Because these are very easy topics, my friend. Very easy topics, and I am looking forward to complete them as soon as possible for you guys. So material requirement planning is mostly a theoretical topic. Okay, na? So materials requirement planning, by the name of this you must have understood that we basically plan our requirement for the materials that we will be using for the manufacturing process, right? So MRP is determining the number of parts, components and materials needed to produce a product, right? Suppose we want to produce Maggi, right? So in order to produce Maggi, we need wheat, so that we can process the wheat and convert the wheat into maida. Then we need all kinds of masalas, right? So those are the basic requirements if we want to make Maggi. So if the final product is Maggi, then the number of parts or the components or the materials that will be required to produce Maggi, number of components, suppose we want to make this bottle, then the number of caps, number of bottle pieces required to produce this bottle, okay? So that will be determined using the MRP technique. Now MRP provides time scheduling information specifying when each of the material parts and components should be ordered or produced, right? Sir, I love Maggi after this module. Okay guys. So MRP जो है, MRP, it not only plans but it will schedule everything for us. Like if we want to make water bottles, and for water bottles we need Or take some other example. Suppose you want to produce chairs. Suppose you want to produce wooden chairs, right? So in order to produce wooden chairs, you need wood, you need nails, you need fevicol, you need paint, polish, tools, etc. So these are basically the requirements of the material that we want to produce this final product, that is the wooden chair. So MRP will basically help you to determine that what are the number of parts, components and materials needed to produce a product. ठीक है ना? It helps you to plan everything for you. So planning by means it will basically make sure that whether we have the sufficient amount of wood or not, whether we have sufficient amount of nails or not, whether we have sufficient amount of fevicol or not. And guys, this will basically be framed, or basically it will be calculated or determined using the requirement of these particular materials: wood, nail, fevicol, paint, polish, tools, etc. through one chair. I mean, through MRP, the system is so intensive that they will calculate whatever the number of wood, nails, fevicol, everything is required for one chair. And if they want to produce like 50 chair, then what is going to be the total requirement of the materials we are talking about? And MRP system not only will make sure that those materials are available with us, if something is not available, then MRP system will send a signal also, so that it can intimate us that yes, nails are out of stock, and in order to produce the upcoming batch of 50 wooden chairs, we need more nails. This much amount of nails, like 500 nails are required in order to produce the upcoming future forecasted project or forecasted chairs. Like we have done forecasting, and through forecasting we can find that 50 chairs are to be produced. And if 50 chairs are to be produced, then the MRP system will basically detect like 500 nails are required, and if nails are out of stock, the MRP system itself will place the order. It should tell us that what should be the ordered or the produced lot, right? I hope you are getting my point. Now how MRP system does this? How MRP system does this? Let me just tell you that MRP system require three inputs. You can see these three arrows. Yeah. So these are the three inputs to the MRP system. It requires number one, the master production schedule, MPS. Number two, it requires the bill of material. Number three, it requires the inventory status file. Now let us first understand what is master production schedule. Master production schedule is a list of items indicating end product to be produced. Like if we want to produce wooden chairs, then depicting or estimating the demand of the product. Like forecasting, we have already done forecasting. Now using the data of 2020, 2019, if we can forecast that in 2021, the company would require to produce 50,000 chairs, because the demand is going to be 50,000 in the forthcoming years. Maggie is the trademark of sir, so when so they give example. I find convenient guys to explain everything through Maggie. That's why I give the example. So that's why today I changed the example to wooden chair, right? So if the company has forecasted that they need 50,000 wooden chairs in the year 2021, so guys, this 50,000 is basically the manufacturing lot or the production lot for the company for the year 2021. Whatever plannings, whatever material procurement the company will do, it will be according to these 50,000 chairs, right? So these 50,000 chairs, with respect to these 50,000 chairs, they will produce a master production schedule, a schedule through which they will be producing these 50,000 chairs. So master production schedule is a list of items indicating end products. Like if in this 50,000 chair there are variety of chairs, like some chair is for 6 foot tall people, some chair is for 100 kg people, some chair is for 80 kg people. So there are different types of chairs also, right? So it is basically a list of items indicating end products to be produced. This contains item name and code. Like if the items are coded, like some you must have seen that in the brochure of various companies, Like Asian Paints, you must have seen the brochure. The color basically has a code like R702. It has a name also, like cherry red or pinkish blue or whatever kind of name is there. But corresponding to the name, there is a code also, right? So the company basically produce everything. So in that production, they give the name and code to the products also, right? I hope you are getting my point. Quantity to be produced and the timings for the completing production, when what batch will be produced, whether this 50,000 chairs will be produced in once, whether you have studied inventory control now. There I have already explained everything to you guys. There is a manufacturing time, there is a non-manufacturing period. Sir, I am really sorry. Please, Mr. Fandu, in fact, please delete your comment. Arey, why are you saying Ashwin? Why are you saying this? No need to say this, है ना? So I am saying that we have already seen in the inventory control. We have already seen in the inventory control that there is a manufacturing period. What is the quantity, lot size? We have already calculated that. So master production schedule basically consists of all those things, right? So first of all, there is a master production schedule. Like what are the number of products that we want to manufacture and what time we have to manufacture it, right? Then apart from the manufacture master production schedule, there is a bill of material, BOM file. What is BOM? It provides a list of materials and their quantities required to produce the end items. Like if they say that in the whole year of 2021 they need 50,000 chairs, and these 50,000 chairs are going to be produced in a batch size of 5,000. So in a year we will be basically producing 10 times. 10 is going to be the batch count, number of times the batches are going to be there, or number of times the production will happen in a year. So 10 times production will happen with a batch of 5,000 units. So corresponding to these 5,000 units, how much wood I require, how much nails I required, how much fevicol I required. All these will be calculated, and these data is going to be in the BOM file, right? So BOM file provides a list of materials and their quantities required to produce the end item. To produce the chair, what is going to be the material, what is going to be the quantity of the material, that is basically there in the BOM file. So BOM file contains the list of finished products, material needed for each finished product in units, assembly structure. Assembly structure is very important. Like when do we need wood, when do we use nails, when do we use fevicol. So in different like workstation, we will be needing different things. I have already talked to you about the assembly line technique, right? So I hope people can relate from there. In different stations, different types of products are required. So assembly structure is also important. Sub assemblies, parts and materials. I hope you got my point, right? BOM file is revised every time there is a change in a product design or specification. If the design of the chair is changed, if the design of the chair is changed, then the requirement for the wood, nail, fevicol, all everything will change. So if there is an upgradation in design, if Maruti Suzuki changes the design of its car, then everything changes. So the BOM file will be revised. I hope you got my point, right? Now this has been shown that for a product A, like this is let's say chair, this is let's say chair, then in the sub assembly one region two products are required, X is required, Y is required, ठीक है ना? Again after some period one more Y is required, then in the sub assembly 2 zone again X and Z are required. Suppose X is nail and Y is wood and Z is fevicol. So it is saying that on sub assembly 1 only nail and wood is required, then some more wood is required, then again nail and fevicol both are required at assembly 2, and at last you can see Y and Z, that is wood and fevicol are required at last, right? So if you can see through these charts, if you can see through this diagram, you will notice that X is required 1, 2, 2 units of X is required, Y is required 1, 2, 3 units, and Z is required 1 and 2 units. So in order to produce one chair, we need 2x, 3y and 2z. So the planning will be corresponding to this only. If somebody will ask us if you want to produce 100 chair, then my friend, we will need 200 nails, we will need 300 woods, and we will need 200 fevicol. I hope you got my point, right? So question like this have came in the examination. Very easy question, very simple question. Now the third is inventory status file, right? Let me just revise this for you, otherwise you people will forget everything. Remember MRP system, it requires three input: master production schedule, bill of material, and inventory status file. So we have already discussed these two. Now I am discussing the inventory status file. What is inventory status file? It provides a computerized record of each material physically held in the system. Right? If we are talking about wood, nail, fevicol, paint, polish, etc. So inventory status file is basically a status of these inventories, of the products, of the inventories of these materials. Like if we talk about wood, the inventory status file will completely have all the information that what type of wood the company has, this type of wood is kept where in the company, in the warehouse where this wood is kept, when this wood was ordered, how much wood is left, how much wood is utilized, everything is known, right? So the computer has a record of each of this data, and whenever through the master production schedule MPS we provide that we are going to produce 5,000 chairs, for which every single chair require 100 units of wood. As we have calculated here, every single chair requires, let's say, 2 units of wood. Every single chair requires, let's say, 2 units of wood. Okay, 2 units of wood every single chair. So 5,000 chair will require 10,000 units of wood. So as soon as we use the master production schedule, the inventory status file automatically will detect whether we have 10,000 woods or not. If, like, say, we have 10,000 woods, then it will calculate then in what time period these 10,000 woods will get consumed, right? And corresponding to the lead time of wood, like wood is a product which has to be in the inventory so that we can build chairs. So this inventory status file will alarm us that this much wood is left now, which is sufficient for the lead time, and now you have to reorder everything. Okay, so there will only be one inventory status for individual material, even if it is used at different levels of production or in different end products. I hope these points are basically clear for you. So guys, MRP system is like let me sum this up for you. MRP is a computerized inventory control system, right? Whatever the inventory we need, wood, nail, paint, polish, etc., in order to produce a final product, that is the wooden chair, then based on the master production schedule, the bill of material, the BOM file, and the last one was the inventory status file. So based on these three, it functions, the MRP system functions, basically on these three input. And what is MRP system? It is a computerized inventory control, which basically tells us everything which is there in the inventory, which is required for the production of the chair. What is the status of that inventory, when we have to reorder, when it will come into the inventory. So everything is according to that. And then it provides us basically with a production plan, that how to produce, when to order, how to do the production process, everything, right? So it basically creates a schedule for each and every items needed. Schedule means, like, whenever there is a shortage of nail, it will automatically detect the lead time and order nails. Whenever there is a shortage of fevicol, it will automatically detect the lead time, and whenever that lead time, that buffer amount will be left in the inventory, it will reorder the fevicol. I hope you are getting my point. So MRP is a computerized inventory control production planning system that schedules component items as needed, which will track inventory also and help a company in many other aspects of business, right? So it is basically a whole soul inventory control system, which not only make sure that how the inventory is stored, but it also makes sure that when the inventory should be ordered and how everything should be managed using a single computerized system. I hope you got my point, right? Let us take a look at this question. This question came in engineering services paper, है ना? So in GATE examination, the question have not been asked yet, but it is mentioned in your syllabus. That's why I am discussing this. A manufacturer's master production schedule is given here. So in week 1, it is planning to produce 50 units. Similarly, 100 in week 2, 3 in week 100, 100, 150, and 50 units in week 6. Each product required a purchase component A In order to make this product, we need a component A in its sub-assembly. Before the start of week 1, there are 400 components of type A in stock. अच्छा, एक product बनाने के लिए if we want to make one product, we need 1 unit of A, right? So we already have 400 units of A on the week 1. Before the start of week 1, we have 400 units of A. That means 400 units can be produced. The produced units can be 400 because we have sufficient A up until this point. The lead time to procure this component, if we will order A, then 2 weeks time is required so that the shipment can reach us. Lead time means 2 weeks and the order quantity is 400. So we again order 400 quantities, but it will reach us in 2 weeks time. So number of component A per product is only 1. The manufacturer should place the order for 400 components in week 1, 400 components in week 3, 200 components in week 1, 200 in week 3 or 400 in week 5. So guys, just check this out. 50 is required in week 1. So at the end of week 1, I can say I will have 350 units of A. Then at the end of week 2, I will be having 250 units of A. Then at the end of week 3, I will be having 150 units of A. And at the end of week 4, I will be having only 50 units, which is not going to be enough for week 5, right? Because week 5 need 150 units and I am 100 short. So basically, before the start of week 5, I need a new order. Right? So when I will be ordering somewhere in week 3. If I will order in week 3, then after 2 weeks I will get the shipment. If I order at the start of week 3, I will get the shipment at the start of week 5. I hope people are getting my point. So if I order 400 units here, I will receive 400 units here, and then I will have basically sufficient number of units for week 5 because I was facing shortage in week 5. I only had 50 units in week 5, right? So the correct answer is going to be 400 components in week 3. The manufacturer should place the order for 400 components in week 3. So because if he will place 400 components order in week 3, then he will basically receive the inventory on week 5 after 2 weeks time, and then he will basically have the sufficient amount of raw material A in order to produce products for further weeks. I hope people got my point, right? If not, just tell me yes or no. I will explain this once again. It is extremely easy. This is the last question that I am going to take. Guys, come on, give me a yes or no. Ashwin has got the point. What about others? Hello guys, is this clear to you? If not, just give me a no. Don't worry, I will explain everything. Hello guys. Give me a yes or no so that I can understand whether you understood this or not. I hope this is understood. This is extremely easy. Right? If not, just let me. Okay, Fundu and Fact is saying clear, sir. So the correct answer is 400 components in week 3, right? I hope you got my point. Because the company has 400 products. Of raw material A, and per product only 1 A is required. So for the first week, 50 A will be required. So at the start of first week, 400 was there, but at the start of the second week, 350 will be remaining. At the start of third week, on the second week, 100 will be utilized, so 250 will be remaining. At the start of fourth week, 150 will be remaining, and at the start of fifth week, 50 will be remaining. So everything was fine up until there. I had 150 unit on the start of fourth week, and the 100 unit was the consumption. But on the fifth week, my friend, I require 150 units, but there are only 50 units in the inventory. So I need more 100 units. So remember, if we place an order, 2 weeks time will be required so that the shipment will reach to us. So it is basically asking when the manufacturer should place the order. So if on the fifth week we are going to face the shortage. On the fifth week we are going to face the shortage. In the fifth week we require 150 units. ठीक है ना? We have 50. So work will go like 1/3 of the fifth week. But if we want to receive a shipment here so that further production can be remain unaffected, then basically I will have to order 2 days back, 2 weeks before, because the lead time is 2 weeks. So when I am ordering on the third week, and whenever I order, I am going to order 400 because this is fixed. The order quantity is 400. They must have calculated the EOQ. So that's why I have taken the answer that he is going to order 400 components in week 3. I hope people got my point. So that is one question that could be there in the material requirement planning segment, right? So these types of questions come, and mostly questions come are from the theoretical area of inventory status file or from bill of material or master production schedule. So guys, that is it. That is the end of the entire industrial engineering and operations research from my side. I have completed what I promised. All the chapters that I told you, I have basically completed all the chapters on this YouTube series. Let me just show that to you. So guys, we have covered LPP, transportation, assignment, sequencing, queuing, PERT CPM. I don't need to worry, Ashwin. I will be back, right? I will be back. Thank you, Ashwin. Thank you, my friend. And guys, let me just tell you one more thing. Let me just go to the slide. From 7th of January 2021, I am starting a new series on YouTube at 9:15 p.m. only. 9:15 p.m. where I am going to start a revision through questions and formula series of I and OR, right? So in this series, my friend, every day I will go live from 9:15 to 10:45 p.m. for 1 hour and 15 minutes, right? In this 1 hour 15 minutes, every day I will take one chapter. I will take around 10 to 15 questions of that chapter, and we will revise the entire chapter through those questions and formula. So this is like a revision session where I will be discussing some concepts also, and I will be discussing questions through formulas. So it is going to be a very short session, like in 15 days interval we will complete the entire industrial engineering and operations research through questions, and it is going to be extremely beneficial for you guys if you are preparing for GATE 2021, because you will be able to revise the entire industrial engineering and operations research, and you will be able to practice lot many questions in just 15 days time. In just 15 days time, my friend, my elective subject I didn't know anything, but now I am convenient with it. Thank you so much from Tamil Nadu. Thank you, Ashwin. So guys, in 15 days time, you will be able to revise the entire industrial engineering and operations research. And remember, the series is going to be starting from 7th of January on this very YouTube channel at the same time that I go live. So every day by dedicating like 1 hour, you can complete the entire industrial engineering and operations research through questions and formula. Guys, I am also starting one more series from the 7th of January, but this is going to be on the special class. And in this series, my friend, I am basically going to cover manufacturing, the subject of manufacturing through questions and formulas. Okay, na? So very soon I will be making a video or I will be making on session. Thank you, Fundu and Fact. So guys, these two sessions are going to start on special class. It will be in morning 10 a.m. to 11:30 a.m. right? So 1.5 hour every day for manufacturing and 1.5 hour every day for industrial. I will also be conducting test of these two subjects, right? So just by dedicating 1 hour for manufacturing and one for industrial every day, I will help you guys to revise the entire two subjects in 15 days, which can help you fetch 25 marks in the GATE examination, right? So I hope this is clear to all of you. If you have any doubt, feel free to contact me. You all have my contact number. You all have my contact number, right? So guys, let me just tell you one more time. Remember, the Unacademy Plus and the Iconic subscriptions are like investment. By opting for the Plus subscription, you can watch multiple live classes in English and Hindi. You can watch different batches. You can join different batches, give weekly tests. Every fourth class is going to be a doubt solving class. On the Iconic package, my friend, Unacademy will be providing you with a personal coach who will be helping you to plan your study sessions, who will be giving you study booster sessions, who will be personally analyzing your test, and Unacademy will be providing you with the preparatory study material, right? These are the subscription fees for the respective plus package of 1 month, 3 months, 6 months, 12 months. But remember, guys, if you will use the code MMM10, 10% will be instantly discounted. You will get a discount of 10% immediately. There is another package by the name of Iconic package, and it is a bit costly. But through the MMM10, the referral code, you will get the discount of 10% on these packages also. Thank you, Ashwin. Thank you, my friend. Okay, so guys, that's it. That's for today's session. Thank you all for watching this. I will see you all at 9:15 p.m. on the 7th of January. Up until then, keep preparing. And guys, tomorrow 9 a.m. I will see you live on the Unacademy special class. I will see you live on the Unacademy special class at 9 a.m. where I will be starting computer integrated manufacturing and material science. So please like, share and subscribe. Up until then, good night. I will see you all tomorrow.